Two, one. Let's go. What's up, everybody? Welcome to another Ask Me Anything session with the Deep Learning Daily community. Our guest today is our guest today is an aviator-wearing, guitar-rocking, machine learning researcher and engineer who eats and digests deep learning research for breakfast. You might recognize him from his YouTube channel, where he's helped hundreds of thousands of people make sense of cutting-edge deep learning research. He's got a Ph.D. in artificial intelligence from ETH in Zurich and is currently the CTO of DeepJudge, a startup focused on using natural language processing for legal documents. Ladies and gentlemen, please help me in welcoming our guest today, the one and only Dr. Yannic Kilcher. Yannic, thank you so much for taking time out of your schedule to join us today, man. Appreciate having you here.
Thank you very much. That was a very flattering intro.
Oh, man, absolutely. For all the help that you've given all of us deep learning folks here, man, it is my pleasure to introduce you. So let's get into this, man. So I've heard you in other interviews, and this kind of slow progression you had into deep learning. You started out by studying medicine, switched over to computer science after a year, took some classes in computer vision, graphical models, big data, and data mining, and the next thing you know, you end up with a PhD focusing on deep learning. I'm wondering, what is it about deep learning that keeps you here as opposed to focusing your time and attention on something else?
Well, I think that's an easy one because everyone else is trying to get into deep learning. There was a short period where we lost some people to crypto, but now it's like it's all back. Everybody wants to be a data scientist and a machine learning engineer. If we open any job position at ETH or here at the company for machine learning anything, you get so many applicants. So I think the field is very much is happening. A lot of relevant things are happening. There's a feeling in the air that progress is being made, which is not given in, I want to say, most of the sciences. I mean, basic non-organic chemistry. I'm sure they have some progress, but I think most of it is in biochemistry nowadays. Also, fundamental physics. I'm not sure how much progress there is, but machine learning, it seems to be, it's like consuming all the other stuff. So I wouldn't want to be anywhere but here.
So you brought up, crypto, and we're losing people to crypto. Lately, I've read some people draw parallels between the hype cycles of AI, generative models, and deep learning in general to the crypto and Web3 hype cycle. I'm wondering, what are your thoughts in regards to that?
Well, I think that deep learning has been around for about as long as crypto because Bitcoin was released in January 2009, right? And AlexNet was 2012, and it's precursors 2011 and so on. So we've been around for about as long, and I feel crypto has established itself as sort of a useful tool for some things, but deep learning is still going strong with like advance after advance after advance. So I think especially in the last year or two, we've seen completely diverging trajectories.
And I've got a question coming in here from one of my colleagues here at DESI. Was curious about your thoughts on the state of reproducibility in deep learning research. What do you think about the current state, and should all experimental results be backed up with code?
That's going to be a forever question. The state of reproducibility has been horrible since, I don't know, for the last 5 years at least. And I mean, now it's bad for a different reason. Now it's bad because people don't give access to either their models or their data sets anymore. Even if they release the code, the code gets smaller and less complicated. So it's easy to release the GPT code because it's just, a bunch of attention layers. But what's important is the data set and how exactly they do the training and so on. So for that reason, it's kind of not reproducible what these big companies are doing. For research, it's still the same, is that even with the code, it's going to be pretty hard to reproduce, let's say, a piece of research. And what I mean by that is to get the same kind of results if you were to do it yourself. So even if you get a piece of code and you actually run it, there's going to be a random seed set, there's going to be the exact data set such that you get the same number that is in the paper. But that doesn't mean that if you change the data set slightly or if you use a different random seed, that you get even near the same result. So I think the crisis in reproducibility is more along those lines, where people, they try out some new idea and they just find that one configuration where it works and they publish a paper on it. But it's more like a crisis of generalizability rather than one of reproducibility as such. Now, given if you don't have the code, yeah, then it's pretty terrible to reproduce a paper. I've almost never seen it successfully done, and I've seen many attempts.
Thank you for sharing that. And everybody in the room, if you guys got questions, do let me know. I'm keeping an eye out on the Slido here as well. A few questions coming in from the Slido. I had a bunch of questions queued up about yeah, what you're like in your 20s and stuff like that, but we'll get to those later. I want to get to the audience's questions here. Question coming in about LLM, large language models, and ChatGPT. They're great, but do you think next set of models are going to be more logical?
That's tricky. It's tricky. If you think of yourself, how much mental effort do you have to expend to really be logical? Like, you really have to sit down. You probably even need a piece of paper once it goes beyond three logical variables to really deduce, okay, if this and this, then that implies this and this. Like, this stuff is hard for a human, and we're building these models in the same kind of fashion I want to say as human thought, sort of this more intuitive, this more latent computation, approximate computation, interpolation, and so on. That's really different from logic. So what I think will probably happen more is that we'll find a way to interface something like a large language model with like a logic computer, or as we see now more and more happening, to interface large language models with programming languages. So the language model can say, all right, I'll do some stuff, and now here I formulate a problem, and then I just execute it as code. And that I'm going to dispatch to like an actual compiler. And then I'm going to take the result, and then I'll go on with my own inference. We humans do that because we use like calculators if we want to calculate some stuff, right? We don't this it's way easier. So I think the easier way would be to make the large language models interface with these things. That being said, it's obviously gonna be, I think, yeah, the next generation will be at least more logical in the sense it will probably reach the like basic common sense reasoning abilities of like a standard human. um just the things that you do in your daily life. I'm fairly confident that with enough scaling and training we can reach those.
Had a friend of mine that had this random thought that he shared with me. He said that he thinks that ChatGPT will push the importance of written communication away from the act of writing to now emphasizing audience curation, editing, and trusted expertise. What does this imply for technical content creators, where there will be substantially more noise from experts, yet the same number of experienced practitioners?
But there's already so much noise from experts. I mean, LinkedIn is a terrible place. If you look at like LinkedIn, that's the place, and that's already happening without ChatGPT. So I can definitely envision a future where everybody tries to become a LinkedIn influencer with like 3 paragraph essays on random things. Um, yeah, I agree with the sentiment. ChatGPT definitely makes it easy to formulate in language something very coherent and something very well sounding. In that sense, it's a great tool. we see more and more of these human like crafts being replaced with tools, and yes, that leads to the fact where the more um, humans will have to resort more to the domain of, as you said, curation, be that audience curation or input curation, of managing things and organizing things and deciding essentially what to use the tools for. Yeah, I agree.
Speaking of tools, got a question coming in from the audience here on Slido. By the way, you guys dropped a link for the Slido there. If you got questions, do type them out, put them there. This question is, will Chat GPT make generative AI startups like, for example, Jasper, Copy AI, and things like that obsolete?
That depends. It's it's not enough to have a good model. That if you're in industry like our company is, you realize that very quickly and very harshly, because what you think is like, oh, we're gonna build great models and people are gonna be super happy. Like, no, they they actually want their work to become easier. They want their work to become more efficient or more pleasant, whatever. They want value. Now, for some types of applications, ChatGPT is already close to really good value, or something like ChatGPT, right? A thing where you can enter something and it gives you the answer. I mean, just look, Google is already like a really good value for a lot of applications. And it's just a text box where you enter what you want to know and then you look for the results. Many people use Google professionally and many people generate value from that, but not all of them. So for a lot of cases, you have to go beyond just the model and you actually have to build the integration of that model into the workflow. You may have to build additional models on top of that model that are really specialized to the domain or to the application that your customers live in. So that's in industry, you realize pretty quickly it's actually about providing value to the customer, not how cool you think your application is. So it depends on how well these companies like Jasper and Copy, how much of an added value they can provide in terms of how much they match their customer's workflow, or how much they benefit their customer on top of the language models.
I'm curious, like, what was your initial reaction when Chat GPT came out? Like when you were playing around with it, was your mind blown? And if your mind was blown, like what aspect of it was so mind blowing?
I think the for people who have played around every now and then with the GPT-3 APIs or the playgrounds of these language models, it was I don't think it was that much of a surprise how capable such a model can be. It was definitely cool to see that with moderate effort, not huge effort, as far as we can tell. We don't know, right? But as far as we can tell, with moderate effort, you can really get these models to like be that assistant consistently, right? ChatGPT rarely breaks character and falls back into just being a language model. It is really that conversational partner, that assistant. Whereas with something like the GPT-3 API, you have to prompt it, and every now and then it's just going to fall back into being that next token predictor language model. But the capabilities were always known, let's say, to people who played with these types of things. I think what to us was more astounding is just how impactful that was on the rest of society. And people try to ascribe it to things like, ooh, the chat interface is really great, or ooh, no, they had this not behind some sort of a paywall or a wait list. Ultimately, what goes viral is it's like a perfect storm of things and then a bit of luck, and then something takes off and the next day it's on Jimmy Kimmel. No one knows why, right? But I think most minds were mostly blown because of just how big it got.
I For someone like me, right? Like I don't got a lot of friends, and I don't got a lot of people to talk to talk to about the stuff that I'm really interested in, unless I do AMA sessions with people like you. So I found it useful for me just to use ChatGPT almost like a just bouncing ideas off someone, but then it's like I always have to check what this thing is saying to make sure it's true. So in a way, it kind of helps solidify my understanding on certain topics. But yeah, it's been immensely helpful. Uh, do you think this? I guess in your opinion, what is like the biggest innovation of Chat GPT, and how do you see that innovation helping deep learning in the coming year or so?
The biggest, at least, impact is definitely it's it makes these models mainstream accessible, or makes them mainstream aware of these models. Uh, because of how easy it is to go there and just type something in, and get a response, and it's fairly clear what you have to do. Or if you don't know, you just type something in, and the thing says, oh, I'm an assistant, right? Uh, Ask me assistant things. If you do it wrong, it will complain. I think it opened the well, it's cliche to say, but it opened the eyes of a lot of people to just what's possible. And I think that is probably the biggest benefits to deep learning, because I feel a lot of places in industry, in government, in whatever, are going to be more receptive to who just think like, could we solve this problem in part by using AI models? And I think that it wasn't really the case before, that the average person would think of this as a possible way to tackle a problem, and now it is, or more, it is more.
Question coming in here from the live stream as well, and it's about ChatGPT again, since we're on the topic. Do you think ChatGPT will create a search technology arms race?
Um, what's a tricky question? There's like a lot of, is it the Google killer or not? Uh, it is. I've been surprised more often than not to make wild predictions. It seems to me, though, that I've been saying for a long time that the next big step of these generative models would be retrieval augmentation. And we already see lots of research around that. So I definitely think arms race may not be the best, but like the combination of the generative models and the retrieval models will probably give us the next kind of jump in performance. My argumentation was always kind of like, you as a human, you get pretty good by going to school and learning a lot of things, right? Like if you ask me right now about the French Revolution, I could probably tell you some stuff that I learned in class. If you pair that with a search engine to like an index of the entire internet, or even just Wikipedia, I will get so much better. And I believe the same thing is true of these language models. If we train language models with all these facts, right, they get pretty good on their own. But if we pair that with their ability to also go and retrieve information from what they already know, and to expand that, to check that, to synthesize it, I think that will be uh, sort of, it will be, or one of the next big pushes in performance and reliability as well.
So changing gears just a little bit here. So I primarily am on LinkedIn, and a lot of folks, especially this sentiment, I hear a lot more on LinkedIn than on Twitter. But it's a lot of people just saying like deep learning is all just a bunch of hype. What would you say to these people who think that is just hype?
Um, in a sense, it's true, right? It's definitely, especially now around Chat GPT and so on. Um, there is a lot of hype. There's definitely a lot of claims about what it will be able to do that, at least in the near future, it probably won't be able to do. So usually the things fade out quickly. Now everyone's like, oh wow, this is so cool. And then naturally people are gonna realize the limitations of it, like, it can't replace me fully in this domain or in this domain. um However, it will stick around, and I think people who say deep learning is just hype, I think there is a decent size of deep learning that just is sticking around as products and as tools in our everyday life. It is now, deep learning systems are deployed in hospitals to do image analysis of medical images, to do biopsy analyses, to predict failure of patients in ICUs, sort of collapses ahead of time, and so on. Deep learning models are deployed certainly in the tech companies. Certainly, they predict your Amazon spending habits and which ads to present to you. So I think that's the natural, almost by definition, that makes it not hype, right? Because there are applications. A lot of it is certainly hype, but I think that's how we progress. We or get very hyped, and then we we research a bunch in that direction, and then two or three things turn out to be actually applicable, and then we hype about the next thing.
Do you think generative AI and these types of technologies have saved the deep learning space from another AI winter?
It's a good question. I don't think so, because you see progress in a lot of other areas of deep learning as well. If you look at what DeepMind is doing, just using reinforcement learning, for example, tackling fundamental scientific problems using sort of search techniques, RL techniques, and so on. So I think there's a lot of progress in that sense as well. There's still a lot of applications in discriminative models and classifiers and so on. Although one could say that the research in that area had been a bit stagnating. It's definitely the case that nowadays the next token predictor type of models are and the diffusion models are pushing forward, but I'm not sure if those hadn't come around, it's not guaranteed that nothing else would have. Like, it's very probable that just something else would have been the flavor of the day, and that something else is just now kind of waiting latently until someone discovers it, and it's just going to be like the next thing. I think there's enough things to be made progress on that we won't run out of hypes for the near future.
Speaking of diffusion models, we've got a question coming in here from Slido, and I'll leave this one up to you if you want to answer this question or point somebody to another resource. By all means, that's okay. The question here is, what are the types of diffusion models? Can you provide a general history of text to image to text to video generation? I will leave that up to you if you want to answer that or point
It's
to
a
another
huge
resource.
question.
Yeah.
I mean, the types of it's diffusion models are just a class of models where you take something and you, I guess diffusion models are models that capture this process of diffusion. So you take something, you apply noise to it more and more and more and more, and then you just learn to reverse that. So if your model falls into that broad category of things, and the category of things that stepwise remove noise and always act in kind of the same domain as they do so, then that could be technically classified as diffusion. There's some math behind it as well. I'm not sure how to classify those up and split those into different areas. There are deterministic ones, probabilistic ones, and so on. Yeah, I'm myself not too much of an expert on that, but the concept has been around for really long, and it's as in many cases in deep learning, it sort of takes someone who to really push it and show the world this is something that actually works and can work and can scale and can work even better than the current models, which only in the last few years have happened. But yeah, it's a bit too big of a question. I would need to do some research to answer it fully.
Next video idea happened right here. right here in in the Deep Learning Daily AMA session. So the interesting point that you made about kind of ideas in a sense being recycled. Like the last few years of deep learning has been kind of recycling methods that were invented in the 90s and 2000s. And I was reading a book, rather listening to an audiobook called Genius Makers, which is like a history of the people and the ideas of deep learning. There's a chapter that focuses on Hinton, and it's called "Old Ideas Are New." I'm curious, what's like a non-obvious old idea that was used, let's say 2022, 2021, or whatever comes to mind that you found to be interesting or unexpected?
I mean, the general, as we just spoke about it, the general class of diffusion models is definitely. I mean, it's not 2021. It happened before to various degrees, right? And all throughout, with a lot of these things, what you'll find is that there is a small group of researchers continuously researching on something until it like explodes, right? And then those researchers they get praised for their foresight and for sticking with the underdog while it was down. Most often they were just like sort of fell into that Ph.D. topic because they already started it or something. But uh, yeah, so that is definitely an idea which is I believe non-obvious. Also, I believe not.
Oh, Yannick, I think your audio cut out there.
Okay, one sec. How about now?
Yeah, good.
Okay. Yeah, so the diffusion models are definitely one where I think it's not obvious, not trivial, and also not too general. Because a lot of these old ideas, they also like it's super easy to formulate them, right? It's very easy to say, I want something that, puts attention on something. It's that is like okay, like Plato had that idea. But to actually implement it and make it work uh is really the name of the game. With the diffusion models, I feel it is a bit more grounded in actual, okay, here is a set of principles, here is a bunch of math, that if you apply it correctly does something. So that is kind of the only example that comes to mind right now.
And questions are coming in on the Slido, so thank you all so much. I'm gonna try to order and sort the questions where they fit. So bear with me. I will get to all these questions. Question coming in here from my friend Lior. He's wondering what will be the next big thing after my model is bigger than yours.
um hmm. It's a good question. I'm not really sure that these companies are into the my model is bigger than yours game as much as it is just currently the case that the bigger models perform better, right? I think they're into the my model is better than yours domain for sure. Um, um, hmm. Yeah, I mean, good question. If I knew, I'd probably somehow find a way to make money off of my knowledge of the future, as one usually can. I'm not sure. I believe we're going to see a lot more applications. So maybe the big companies will go more back into the domain of actual applications rather than research, because these big companies, they have been focusing on sort of core research for the last years to a astonishing degree, right? The amount of money that like Google, Meta, and so on have just spent on, yeah, basic research is astounding, right? Which they're companies, they need to make money. So maybe with all these new possibilities, we might also go and see more of kind of like a productized um, type of research, which is something you already see with like Chat GPT and Dolly and so on. Although OpenAI isn't necessarily one of the tech giants.
There's another question coming in. I think that fits nicely here. It's kind of related to practice it at different companies, but is ensemble learning, blending, etc., the practice for most companies that you've seen?
It's definitely a good way. It's applicable for some things. Yeah, I think a lot of companies. So, I mean, the dirty secret of machine learning in industry is that for most applications, it's completely fine to use like a bunch of basic classifiers and then train like XGBoost on top to produce an ensemble model like suggested. That's completely fine for 95 or 99% of actual use cases of machine learning in industry. So yes, in that sense, for most companies, ensemble learning on top of relatively simple classifier like logistic regressions, SVMs, and so on is going to be a very good practice, unless you really are into natural signals like images, sound, natural text, and so on.
So that 5% where that wouldn't be applicable, would it be in those scenarios that you just described?
Yes, deep learning
Yes.
really shines in these unstructured natural domains. We've seen deep learning come into tabular data and things like this, but it's going to be a rare case where it really pays off, like the extra cost that a deep learning model takes, the extra resources that it takes versus the extra benefit that it gives you. That's a rare case, I would say. So mostly you'll find deep learning where you'll find image data that can't easily be analyzed using classic OCR or computer vision techniques, or where you have speech or sound data that can't easily be analyzed using classic techniques. Essentially anywhere where a natural signal exists and the classic techniques fail, that's where you'll find deep learning applications in practice.
Another question coming in from the Slido here. Apart from generative AI, what do you reckon are some new or potentially disruptive trends in computer vision?
Um, so the entire stream around nerfs, I think, is very is whether that's considered computer vision. I would consider it computer vision. I find to be very, very astounding that the whatever your thoughts on the metaverse are, uh, being it, I've seen now people are able to, from a short video, essentially create a scene where you can step into in VR or in AR, in 3D, and move around, and it's fairly accurate as the scene you've seen sort of on the picture on the video. So that whole domain I find fascinating and is also making progress at a enormously rapid pace. Um, and obviously, that's also you'll find like companies like Nvidia pushing that really hard because it's up in the intersection of all of their domains, being graphics, machine learning, vision, and so on. So there's lots of power behind that, and also Meta, given they want to start the metaverse and all. So I'm more bullish on metaverse like things than I was at the beginning after sort of seeing this really cool progress.
So was it the nerfs that kind of turned you into the believer then?
Yeah, the whole yeah, and the speed, right? The speed by which it progressed. Nerfs, when they came out, they still used lots and lots of rendering time, and you really had to have pictures all around. And now it's like you swoop with the phone a bit, and that's probably almost like in a year that's gonna be enough to make a fully immersive scene out of essentially whatever you just filmed. So I can't like I can't imagine the uh, the metaverse or so on getting any easier than that. Or if maybe not for the things people predict now, but just imagine showing your holiday pictures to someone and you can just invite them there. You can just be like, look, look where I was. Come, experience it.
I was at ECCV with my company Desi in at the end of October, I believe it was. A- Amazing conference, and I'd say I got a chance to walk all up and down the posters section for the 3 4 days I was there, and I'd say 25% of the research that PhD students were doing were all about nerfs, and it was just fascinating, fascinating. Just a question, just thinking about, you mentioned uh, the metaverse, and just like taking a phone and just kind of getting there. Um, I guess what implications does this have for the metaverse meets like the edge and deep learning? I don't know if this question is making sense, but hopefully you're kind of catching my drift. But I'd love to hear your thoughts on that.
Yes, I mean, um, by edge you mean sort of edge devices, edge or
Yeah,
more.
yeah, yeah. Edge devices. Yeah,
Yes, I'm not sure. I mean, given the current state of deep learning, it's always going to be more efficient to just have edge devices that stream really fast to some central server farm and then are able to receive feedback for whatever they want to do than somehow computing locally. You're going to need still pretty beefy edge device. Depends on the application, of of course. But I foresee a future where all your devices will be smart, but in a way where they all communicate with some central instance rather than deep learning running, either distributed or on each one of them. It could be that we're going to make huge progresses in sparsification and quantification and pruning and slimming down that actual serious edge computation becomes possible. I'm not sure that's going to be the case really soon, though, especially in a domain like nerves where you are going to need, rendering, so meaning graphics computation and so on. So it's probably still going to require heavy duty gear, but that can be hopefully with internet speeds maybe the limiting factor there. So I'm not sure how that's going to develop.
thank you. And just continuing on with the questions from Slido, you guys are keeping it coming, man. These are great questions. So, question again, since we're on the topic of computer vision, I'll try to. There's a bunch of questions on generative AI, ChatGPT, and things like that. I'll try to lump those all together. Right now, we'll stay on the topic of computer vision, and then move on. Question here is for computer vision: what are the use cases for panoptic segmentation or semantic segmentation? Are these better than object detection?
It's a good question. The segmentation things are probably going to be, at least right now, useful in, well, first of all, certainly in sort of editors. So Photoshop-ish type of things, or if you imagine that same thing for video, I'm not sure what the current status of Runway ML is with their sort of video editing and so on. But if I can segment an image really well, really get the pixels down to what is what and have an understanding of the scene as I'm looking at it, then obviously I can edit. I can say, well, take out the house or make the dog into a cat or something like this. And that almost requires sort of a scene understanding down to the pixel level, at least to some degree. Probably for most applications, object detection is going to be fine. If, like, I doubt that a self-driving car will need an accurate, like, what's the exact spatial occupation of the pedestrian, rather than just saying, well, here's a big box around the pedestrian, don't go there. Like that's going to be probably even preferable to a semantic segmentation. So that's where I see the semantic segmentations more in the sort of editor type things, and again in the maybe VR AR type things where you want to interact with the scene in a detailed way, um, in some sense.
Another question on computer vision here. Yellow V5 seems a good fit for edge devices. Does it mean faster RCNN and other two-shot detectors become passe?
Well, it depends how fast you can make the two shot So it whether or not something is a one shot or a two shot detector, obviously two shot takes two steps. But if the one step takes really long, then you know that's ultimately it comes down to actual time, latency, and that's going to be a property of many things, like how what your model architecture is, but also what your hardware is, how well they fit together. Um, yeah, that's a. I'm not sure any architecture is going to be passe or not. Um, it will probably heavily depend on the use case.
So, gonna switch into a chat GPT mode here because there's a lot of
Sure,
questions on there. So first question is actually to kind of set the stage for this next question. So you've got a company that you started, a startup, DeepJudge. So talk to us real quick about DeepJudge and what it's about. And the question here is, how is DeepJudge looking to leverage chat GPT? Are you looking into chat interfaces within DeepJudge?
so we are building tools for lawyers in its most basic um, sense that I can formulate it. Right now, we are building search engines for in-house document collections. So a lot of these big companies, they have tons and tons and tons of documents internally. Obviously, they can't search that using Google because Google can't reach it. And the internal search engines that are accompanied or that are packaged into their document management systems, they're usually really weak. So we build modern search engines for those documents, which means we often, for example, deploy on premise. Even if not, we have really sensitive data, which we often fall under attorney client privilege. For that reason, using something like ChatGPT, sending data to some American company is an absolute no-go. So we're not making use of chat GPT or it at all for doing anything businessy with customer data. It is obviously has not passed us that people seem to love to interact with language models using sort of a chat interface. And I think a lot of companies are now kind of thinking about how to do that, but we'll have to see whether or not it makes sense in our context. As I said, we're right now building search engines. I think you.com sort of made an initial attempt of pairing search and chat. And I think we'll observe how that works out and what we might learn from that.
Chat GPT question again. Is it fair to say that Chat GPT is more useful to an expert who knows what to do and what they want to get? Time winner tech, basically.
It's it depends. I believe even for a beginner, it's really great because it can also tell you what to look for. Uh, so I think it's useful throughout. It's it's probably not. The question is more like, where is it not useful, right? Is probably not useful when you're actually looking for a literature reference, um, that exists and so on, but you sort of want to get that reference. It's probably a search engine is probably better because ChatGPT will just make up stuff. Like even if it doesn't exist, it will just kind of give you names of authors and years and the paper titles. But I think, yeah, for an expert, it's definitely cool because you know what to get and what to get out of there if you ask for the right things. But also for a beginner, you just enter, hey, I'm interested in such and such topic. What should I be looking at? I think you will find you'll get pretty decent answers.
When it does hallucinate and just make up an answer, it is quite convincing. I was just playing around with ChatGPT yesterday, and I asked it. So apparently, it's not trained on any data past 2021 or something like that. And so I asked it to describe the Conv Next architecture, right, the one that just came out in 2022, and it laid out like some pretty convincing sounding stuff about what Comnext was, which is all completely wrong, but it was still fascinating to see it with present that with such conviction. So I guess let's get a little philosophical here. So, uh, since we're talking about Chat GPT and chatbots, it is a form of intelligence, kind of in a way. But I'm wondering to you, what does it mean? Like, what does intelligence mean to you?
That is, I'm just, I'm completely holding off on giving any definition. There are countless definitions, and whether or not ChatGPT or anything like this is intelligent, uh, entirely depends on your definition. It will fit some, it will not fit others. For the ones where it is a graded spectrum, it will fall somewhere on the spectrum above a pair of scissors and below a human, but not much more to say there. Yeah, I'm I'm really not sure. And then there are the people who are like, I know it when I see it, which is also not super helpful. Um, because I'm pretty sure if they were to see ChatGPT like embodied in a human, they would say, yes, that's intelligent. But when they know it's a chatbot, they would say, no, that's not intelligent. That's just kind of a trick machine. It's, to me, this is a meaningless question almost. Not
Mm-hmm.
fully meaningless, but it is pretty meaningless.
So if AI were to have like let's just say an internal monologue, just running through his head all day, what do you think it would be like? Would it be like in English? Would it be incomprehensible? Would it be dependent on the training data?
Well, the question is, I think, okay, this is my thing. I am much more fascinated by what these models tell us about, or could tell us about ourselves, than what we hypothesize what these models know or don't know or think or don't think. So the question that's raised is obviously, is your internal monologue really English, or is it only English when you're paying attention to it, right? Because
Mm.
I'm usually like, when a thought pops into your head, that usually happens much faster than you could speak the thought or even think the thought in English. You have sort of your conclusion reached, like, okay, so that can't be English. That must be some latent thing, right? Is
Mm.
it? Is it not? Are you really doing more than interpolating your training data in kind of a smart way? So I'm much more fascinated by the question it raises about human intelligence than, you know, I'm not sure what kind of internal dialogue it has. If I had to guess, I would say it has like a latent internal dialogue, because those are the states that are kind of propagated as it does the inference, propagated through the layers. And if I think of an internal dialogue, that's sort of the analogy. Um, yeah.
I like that. Thank you. Thank you. Thank you for entertaining those questions. So more questions coming in here. There's a couple on kind of generative type of stuff here. One question is about diffusion models. So will diffusion models be the trend, or will VQVAE or GAN models, be the trend?
I mean, as far as I am aware, the current sort of a lot of the current diffusion models are based upon VQ VAEs, or VQ, even VQ GANs. So there you have everything in one, right? you have the GAN aspect with the discriminator, you have the VQ aspect with vector quantization and re-encoding, and on top of that you have the diffusion model. So what usually these models do is they pre-train some VQ GAN, and they use that as an encoder to a latent space. Then in the latent space, they do diffusion. That's, I believe, stable diffusion was initially called something like latent diffusion, or something along those lines. And then they use the VQGAN decoder again to decode that. So these techniques can be mixed and matched, and that's exactly what we see. So probably the going forward, we'll see probably more of a mix of, I take, the best things from here, the best things from here, the best things from here, and the combination is maybe what's going to be the best.
All right, so let's get into some other question topics here. We got David from Hungary. Thank you for not being anonymous, David. He wants to know if you can recommend a university or a city or company that is a leader in NLP. David just finished his university's BA and fell in love with NLP.
Um, I think, well, partially due to the pandemic, and also I think just partially due to the hype cycle being on a downward slope. It's no longer the case that Silicon Valley is kind of the only place where you can do sort of big modern tech stuff. So that stuff is a lot more distributed now. So I couldn't even tell you where to go because a lot of places are popping up with. I mean, Zurich here is like by many standards, the most boring city in sort of the European continent, at least. It's very quiet. People are very kind of, I want to go to bed at 9:30. And we see a lot of NLP startups popping up here. Berlin is not a boring city, but also there a lot of machine learning NLP startups popping up. London has always been kind of booming, but it still is. I mean, okay, DeepMind is there and all. Ireland is booming. Paris, Hugging Phases in Paris. So I think many places are very, very welcoming now. And it's more like it's been more and more distributed over the last years rather than centralized, which is really cool because that means you can more just kind of see around what you like. But it's really comes down to a personal preference. Me recommending something is probably not the best way to choose your future.
I just something about Zurich. I was there back in 2008, such a long time ago, for just a couple days, and it was over the Euro Cup that I was there, and I
Mm-hmm.
remember like just the streets were crazy until 3, 4 in the morning, like, and there's shit everywhere, just like stuff everywhere, and I woke up a few hours later, and the streets were like spotless, like
Yeah, yeah,
completely spotless, and
we
I was
have
like,
that. Yeah, every year there's this thing called Street Parade, which
uh,
I'm not sure if you've ever heard of, like the Love Parade in Berlin. I'm not sure if they do that anymore, but the Street Parade is pretty big and internationally also pretty big. And the same thing, like the day of the Street Parade, everything's covered with crap and garbage, and then next morning, like spotless, really nice.
So let's learn a little bit more about you as a person. Great questions from everybody coming in. I really appreciate all that. But we're talking a little bit at the beginning, top of the hour, about kind of your background, and how you got into deep learning. And like me, you didn't grow up with any technical people in your family that can serve like as a mentor or show you the way. And I think I've heard you say in an interview that you actually didn't even get into coding until you're in your 20s. Personally, like I was still candy flipping at raves and abandoned churches in downtown LA when I was in my 20s, and it really wasn't until my late 20s that I went back to school at UC Davis and started to learn R and get into coding again. But I'm curious, like, what were those early years like for you? What was Yannic Kilcher like in his 20s?
Um, I mean, I entered university. I did I think my first coding ish was my so in high school you have to do like a senior project, the equivalent of a senior project in the US, or where I did program a little bit. I really didn't know what I was doing, and in hindsight, it was very wrong. Um, but I did a little bit of programming, which would have been at 18, 19 ish. Um, yeah, then I started doing medicine as a subject at university because I passed the test. So I thought, well, that's really cool. I passed the test, so I should probably study that. And then after a year, I switched over to computer science because it really wasn't that much my thing. And then there, I started programming just as in university, you have courses, you learn to program. I think I wasn't really special in that sense. I learned along with other people, and I got hired at some point as a software engineer after I think my second year at university, which I think boosted my learning, just knowledge of coding and how to program. Not necessarily a lot of people who start to code, they think once they know the language, it's kind of there, they know how to code, but it's really only the start, I think, as we most of us are hopefully aware, is that then you're like ready to learn. So that boosted me a lot. Yeah, but it wasn't anything special. I'm not a master coder still, so
I, I speak to a lot of people in their 20s, and for some reason, a lot of them just feel like they're behind on stuff. And it's like, dude, I turn 40 next year, and I feel behind on a lot of stuff, but I'm still out here making it. Is it ever too late, or are you ever too old to get into coding or deep learning, and or pursuing anything that you're interested in, for that matter?
I don't think so. Obviously, having an educational YouTube channel, you more viewers is better. No, but no, but it has to be interest driven. I see many people, especially nowadays, who yeah want to get into being a data scientist and so on because they see it's a good step career wise. Uh, it it tends to be harder to learn something if you do it like as a career move. Some people are really fierce in that, but it tends to be harder than when it's out of genuine interest. But if that's there, I don't think there's anything or anyone stopping you necessarily.
Do you need to be like exceptionally gifted in mathematics or computer science to have a fulfilling career in deep learning?
Gifted at prompting um nowadays, I guess. But no, no, I think I mean there's always gonna be certain topics that require really some special kind of abilities. There are certainly topics that require exceptional mathematical abilities, but those would be more if you research, if you go into research in theoretical deep learning and research neural tangent kernels and how models converge even though they are non-convex, and if you go into that type of stuff, yes, you probably, some people are probably just not going to be able to sit down for long enough and study these things hard enough to achieve a level where they can take part in the research community, especially if they start being older. But by far, the most areas in deep learning are totally accessible to anyone with enough interest, and yeah, and it requires some time to get started.
If anybody has questions, do let me know. I've got a bunch of questions queued up here for Yannic. I'm just going to launch a poll real quick. For those of you that are still here, please do feel free to fill out this poll. It does help me. So if you have questions, let me know. Feel free to raise your hand, come off come off of mute and ask your question. Be happy to take them. But let's just talk a little bit about reading papers. So you're known for getting right to the core idea of a particular paper and how it works. So when we're out there independently reading papers on our own, how do we go about identifying like that core idea?
I mean, that depends a little bit if you know the surrounding literature or not. If you do, it's going to be probably fairly easy, because you know kind of what other papers are doing in that domain, and then you are fairly easily able to spot, oh, all of this stuff is kind of the same as in all the other papers, and here is that kind of two paragraphs that are different. So that I think helps a lot. So if you know already you are going to read multiple papers in a new field, then just don't stress about the first paper. Just kind of read it. Even if you don't know, what is new, it will become clear later. If you just read one paper in a domain you're not super familiar with, and you have to figure out what's the core idea, then it's a bit harder. You rely on your general ability to read papers. Most authors are nice enough that in the first paragraph they say, here are our core contributions, and they list like 4 bullet points, and usually the first of that is like the main thing. I can't really say more than that. Then it comes down to case by case thing.
So like the pace of new research being released on archive for deep learning, it's so difficult to keep up with. I saw a tweet a couple days ago, and it said something like we're only 1 week into the new year, and there's already 600 plus papers submitted to archive on deep learning. That was mind blowing. As we read through these titles and these abstracts of filters, as we read through the titles and the abstracts of papers, what filters should we have in place to kind of judge whether or not a particular paper is going to be useful to us, or something we should just leave alone?
Um, Mostly interest. So I've always selected papers that I read just based on interest. Um, Not really based on how impactful I think they are or which lab they're from. Although that obviously it helps when it comes from an author whom you respect and who you know does great work. So that usually helps. But to me, it was always just interest. It's just like, am I interested in the domain? Am I interested in the problem that the paper is supposedly solving or tackling? If yes, then I consider it readable.
Do you have a personal knowledge management kind of system in place to manage your relationship with information? And like, if so, like, what does that look like?
I have about 12, and I've started each one of them, and then I aborted at the first sign of so I'm usually good at organizing until I get overloaded, and then that's kind of the first thing that drops away. The which is really bad, right? That should be the last thing that drops away, your organizational system, because that's what will allow you to get back on track. But to me, that for some reason I can't keep it going. Um, right now is again a time where I'm kind of super duper overloaded, and my email inboxes are completely overflowing. My task manager is absolutely out of date. Nothing is. I just do random things. So I'm not a person where that type of thing works. The only thing that consistently works is an app called Pocket, which is like a read
Mm,
later app
yeah.
that has browser plugin. It has a phone app, right? And wherever when I see something that I like, I just put it into Pocket, and then I at least know where I go search for that thing. So then I can go to Pocket and search, and a limit like, okay, limit to last month, search for this and that. That's the only thing that really consistently worked for me. Nothing else.
Yeah, rather than having like 150 tabs open, just have everything in one place. I do something similar. I use my Read It Later app of choice is called Matter.
Mm.
So I'll save articles, whatever, into Matter, and then I'll go into Matter, read it, then I'll do whatever highlights I need to. The highlights automatically sync to Obsidian for me, and so then
Yeah.
once it's in Obsidian, I'll just take notes or distill it down further, and just do whatever expression I need to do from that. There's some questions I missed from the live stream here, so I'll get to them, and I think they kind of fit in place here. My friend Mike Nash here is saying, "What is the with the explosion of ML AI papers? What do you think of the quality versus quantity? And is it still a great way for publishing research, or is there a better way?"
It's a good question. Well, the quantity has certainly gone up. The question is, has the quality gone down, or was it always kind of low? I would argue a lot of research has always been kind of low quantity because, I mean, most people aren't exceptional by definition. I'm not saying that, I strongly believe most people are, especially in research, are smart. They are working hard. They're doing their best, but just by definition, there's a distribution, and some people are exceptional, and those are going to be few. And so, most research that will come out is going to be just kind of smallish, kind of incremental, kind of just pushing the state of the art a little bit, just expanding on a theory in this special case or in that special case. And that's fine, right? And yes, with the influx of more people into this field, naturally, everyone needs to get their PhD, everyone needs to get their grants and so on. So they need to publish. So they'll publish more of that stuff. So quality versus quantity. You can make the argument that with the more quantity, the average quality has sort of regressed more towards that middle where it's more kind of like average research, like, or not average, not earth-shattering research. So if you pick a random paper, it's probably not going to be very disruptive. Although I would not necessarily say that is a bad thing. We are still making decent progress as a community. As far as publishing research goes, it depends. You do definitely need to make a little bit of marketing for your research nowadays. It's not enough if you just publish it at a good journal or at a good conference. NeurIPS is huge. They accept how many thousand papers every year? So, even if you are one of those, it's not like people will be like, oh, you're the person who published at NeurIPS, right? Upon seeing your name, because you were even the first author of a paper there. So you do need to make a bit of a fuzz about your paper, but that doesn't have to be too much. You don't need to be like on a crusade to publicize yourself. But it's, in general, I believe you still publish in journals and conferences because that's just how science works. Peer review is still a necessary part of the scientific process, although we could think of maybe doing peer review in a different way. Until now, if you want to get your PhD, you still need to go through these institutions for better or worse. And you need to maybe additionally do a tiny bit of media work.
Another question here from Mike. Mike says he's a huge fan of your ML News segment. So he says, when it comes to researching this, every week or every month, from the research that you're seeing, are you seeing any AI ML research increasing, and are there any key trends for future years?
It is come to a point where I myself can't keep up, right? I had to at the beginning I did it more frequently. I really did it every week, and then there were weeks where it was, I guess journalists would call it a slow week, where not that much happened, and I had to go fish a bit on and go to Google News and see if there's any funny stories about AI. Usually I easily found something, right? There was never nothing going on. There is definitely a complete intensification of things that are happening also on a grander scale. I don't foresee too much trends except for this trend that we currently see right now into more productization, into more the companies keeping the models to themselves and looking to sort of build them into products and then sell them to you, sometimes under the guise of safety, sometimes just not just being honest and saying we want to make money. But that is definitely a trend.
Mike's got another question here. Mike's coming in hot with the questions, man. Great questions here. His questions is related to edge and computer vision. We're seeing a lot of AI dedicated chips being developed. How important will hardware play in AI development?
I mean, it's essentially the history of deep learning has been the history of hardware development. The two have been extremely closely linked. Now, there have been long predictions, let's say, of different hardware will change the paradigm. For example, edge, right? Or what if we could build hardware that allows for more sparse models? What if we could build hardware that allows for more distributed models? All these types of things. What they miss is that there's just this sort of network effect of hardware is built for the models that are being used, and the models that are being used because they fit the best to the current hardware. So we've seen people claim year after year that, oh, we are on the verge of the new hardware paradigm, and it has not happened so far. So it might very well be that new hardware paradigm is around the corner. I don't I'm not sure that will happen. What would need to happen is that the new paradigm would have to fulfill either a significant niche that the current paradigm isn't that can't easily access, and it would have to do so from day one. It can't be like, here's kind of a sucky product, but it's a different technology, right? No one cares. So you have to be at least as good, or you have to support kind of the same models, but be a bit cheaper. And then people will see, oh, that's kind of a bit cheaper. You'll get some market share. And then people realize, oh, I can also develop these other models on this new hardware. And that's maybe how you can make a transition. But just out of the blue, coming here with, oh, we support graph neural networks, but we're super expensive and no one builds graph neural networks. That's a risky proposition.
Another question from Mike here. What are your thoughts on symbolic AI, and how do you see it influence the future of AI?
Yeah, maybe it reverts back to at the beginning we talked a bit about logical networks and so on. With all these discrete things, I always keep in mind that you as a human, you seem to be able to do discrete computations while your hardware, it appears to be, it's discrete, it's spiking, but it is in essence sort of this continuous blob of non-symbolic matter, right? Of connected non-symbolic matter. So it seems to be perfectly plausible that hardware or a system like this implements symbolic computation. Although also, as I've said before, you have to really focus in order to do that if it gets complicated at all. So I'm not sure at all. I don't Yeah, I would love to see the two interface. I would love to see the sort of continuous model things, being able to learn to use some sort of symbolic processor to do their thing. But I would also not be astounded that if we scale up more, that something like simple symbolic computations will just become an emergent phenomena, like simple math is an emergent phenomena now in these large models.
We'll begin to wrap it up. I got just a couple questions here. One from Alina, who's still here. Alina wants to know what's your take on the future of legal AI?
Legal AI, like meaning maybe AI for the legal domain. Um,
Uh, yeah, let's assume that.
yeah,
Yes, and she says yes in the chat here. Yeah.
it's tricky because a lot of legal so there's, for example, tax law, and tax law is purely computational, right? It's like this percent of this much done. So that's very algorithmic. You don't even probably don't even need deep learning except to recognize like the slips of paper that some cashier hands you for the expense computation or something like this. The rest of law is not only very mushy, which would mean deep learning would be actually a good fit, right? That's why we are also in this space. But if you want to push it further, and let's say you want the AI to actually implement laws or decide on laws, something like this, then very often you'll run into, I think the Americans call it like a reasonable person standard. So that's where the law kind of it's essentially it's defined like what would a reasonable person do, like what would Joe from Springfield, who is like a fairly average guy, do in that situation, and is it reasonable that Joe should have expected that if he left his car on neutral and the brakes off, that it would roll down a hill or not, right? And for that, and that gets more tricky if you think of assessing that with something like a language models, or do we need something like really embodied AI for that? Like AI that has been in the world, that has interacted with the world and actually sort of makes its hypotheses and its tests about how the world works. And so the question is more like, do you need a human experience to be accurately able to assess that reasonableness standard? Because so much in law actually hinges on this reasonableness. So that's why I see the domain of making legal decisions being pretty far away. Not only because people are probably going to be really scared of outsourcing that to a machine, but also because of this. So I think supporting the humans in legal, because there's a lot of natural text that's really accessible because there is a lot of natural text, right? That's a really cool domain for NLP. But then going further and automating it, that might be a bit more tricky.
So begin to wrap it up here with this final question. So huge shout out to Dean Plevin, CEO of Dags Hub. He's the one that got us connected. Dags Hub doing awesome stuff. I was listening to your interview with him on his podcast, the I think it's called the MLOps podcast, and during that time, you were watching a lot of documentaries and analyses on how YouTube channels or in general more popular things fall in or out of fashion. I'm curious, like, after having watched those, what have you learned about that, and what are the major lessons that you've kind of taken away from that?
Um, well, it's tricky because you always have to innovate, but you also always have to kind of provide that core value that people return for. I think for me, it is people return to learn something about AI, about machine learning, be that to learn the newest developments or to learn something about a given paper or something like this. I think that's why people show up to my channel, and maybe the occasional funny project or something like this, where it's more like entertainment. Yeah, at the same time, you kind of need to innovate so it doesn't get boring, let's say. Um, I'm trying. It's some things fail, some things succeed, but I'm constantly trying. At the moment, we are. I've I've been down on the videos a bit because I'm focusing on a project called Open Assistant, where we try to replicate ChatGPT in open source. So the goal is to make not only the code but also the model fully available. We're really pushing hard on, like, every waking minute of my life is going into that currently, and it's going to be really cool. And I hope that will obviously flow back into the YouTube channel, make for really interesting set of videos, and yeah.
Yeah, I saw your retweet or quote tweet. It was Logan's was asking about what they could do at OpenAI to make the developer experience better, and you're like, just give us the weights, man. Release the weights.
I mean, it's obviously a bit of yeah, I'm super fine with companies making money, right? I'm like a capitalist. Like, they build the model, they want to keep it to themselves and let everybody pay for it, or get a big exit, right, for themselves. That is cool with me, like, good for them. It's just so funny how when they started, and still they're like on this, oh, we democratize AI, we are the servers of the people. Like, no, you're not. Like, no, like, don't don't do that at the same time. Like, it's just the the contrast is what's funny. Not, and this, my comment was obviously a bit tongue in cheek.
Yeah. So just going back to that point about how you're researching stuff, and how things fall in and out of favor. If we kind of extend the lessons that you learned from watching those videos and documentaries, how does that apply to ideas in deep learning? Um, if that question makes sense.
Um, it's a good question. I'm not I mean, maybe it's essentially a lesson for the field as well. You have to keep pushing, you have to keep innovating, but also you have to stay true to the core principles. I'm not sure if I'm interpreting your questions correctly, but I'm always fascinated by sort of the more skilled researchers. They always have this ability to go back to sort of the fundamentals. If you listen to, I don't know, Ilya Sutskever talking about AlexNet, I believe he was part of the AlexNet team, yes, under
Yeah,
Hinton, and
yeah,
he would say, I've listened to an interview, and he would always say like, you know, it was completely clear to me that this must work because that's kind of how humans do it. So the brain with this and this hardware seems to be perfectly able to solve this problem. So I didn't see why not, and it seemed it made about sense that at this size of data and network that should work. So the sort of confidence that can give you to drive forward and push for something unknown, to just reason from first principles. I've always admired that deeply in people, and it really seems to be a correlation between how successful and how skillful researchers are and their ability to stay grounded in these first principles. So that I think is something one can learn as a synthesis of these things.
and with that, I think we'll go ahead and wrap it up. Yannick, thank you so much for your time. I really, really appreciate it. And to the audience and the amazing questions you guys asked, thank you so much. I really appreciate you guys' participation as well. Yannick, thank you so much, and looking forward to all the awesome stuff that you're going to be up to this year.
Thank you so much for having me.
Cheers, everyone. Have a good rest of the week and take care. Bye.